Okay, this second part, so 9-2, is all about arithmetic sequences. So arithmetic or arithmetic, I'm going to say, is when you're adding numbers to get to the next term. So like 2, 4, 6, okay, I'm adding 2 every single time. It could also be subtracting. So like if I go from like 0, then -3, -6, -9, that means I'm subtracting 3 every single time. When you're adding or subtracting, the number that you're adding or subtracting by is called the common difference. So here are your two formulas you have to know. Common difference, that's what you're adding or subtracting by. Okay, in terms of arithmetic sequence, the formula is dn plus c. Well, the d is the common difference. That's the number you're adding or subtracting. To find c, you take a1, which is your first term, minus that common difference. So if you know your first term and you know your common difference, you're going to be able to write an equation. So those are the two things that you have to know. Okay? So first term. We'll get to sums here in just a little bit. But when you're finding the sum of a finite, starting and ending, we're not going to do infinite on arithmetic sequences. Okay? You do n divided by 2. N is the number of terms. So however many terms you're trying to add together, that would be your n. Okay, divided by 2. A1 stands for the first term, AN stands for the last term. So you have to know where you started, where you ended, and how many terms there are. Once you know that, you can find the sum without actually having to add every single number individually. Okay, so we'll use the formula. Alright, so we aren't going to get to the sum until after we get through this first part. So this first part, either A, you're going to just use your brain and think through it, or we're going to be using this equation. Okay? So the first part says, determine whether the sequence is arithmetic. If so, find the common difference. So, yes or no? If it's yes, we have to find the common difference. So I have to see, am I adding the same number each time? Well, if I'm looking at number 1, I start at 10, then I go to 8, so I'm subtracting 2. Then I go to 6, subtracting 2. Okay, if this is the same number every single time that you're adding or subtracting, then it's an arithmetic sequence. So this would be yes, and my common difference would be -2, whatever that number is that you are adding or subtracting. Okay, multiplying, that's not arithmetic, that's geometric. So these are literally only adding or subtracting. Okay, if I look at number 2, to get from 1 to 2, I added 1. To get from 2 to 4, I added 2. That's not exactly the same number. They have to be the exact same. And positive and negatives matter. If one's positive 2 and then you're adding -2, that's not the same thing. You have to add the exact same number every single time. So if it's no, there's no common difference. Okay, next part says we're going to write the first 5 terms, which is what we talked about yesterday. If the sequence is arithmetic, then you're going to find the common difference. It says assume n begins with 1. So that means we're going to start by plugging in 1. So I'm going to plug in 1 to all my n's, so I only have 1 n on this one. So 3 times 1 is 3, plus 5 would be 8. Find the second term, I plug in 2. 3 times 2 is 6, plus 5 is 11. Then I plug in 3. 3 times 3 is 9, plus 5 is 14. Plug in 4. 3 times 4 is 12, plus 5 is 17. Plug in 5. 3 times 5 is 15, plus 5 is 20. Okay, that answers the first part of my question. Then the second part says, is this arithmetic? If so, find the common difference. Well, look at my answers. Am I adding the same number every single time? Well, to go from 8 to 11, I added 3. So look to see, does it add 3 every time? 3. So that would be yes. So then I put what my common difference is. So my common difference on this one would be 3. Okay, so there's 2 parts to that. Now, if it's not arithmetic, then you don't do the second part. It's just if it is. Okay, 4. So plug in the first, plug in number 1. I have 2 n's, I have to plug them into both. If I plug in 1, -1 to the first is -1. 3 times 1 is 3. So that'd be -1/3. Plug in 2, negative 1 squared, positive 1. 3 times 2 is 6, so this is positive 1/6. Put in 3, that would be negative 1 over 9. If I plug in 4, that would be a positive 1 on top, 12 on bottom. And if I plug in 5, I'd have a negative 1 on top and a 15 on bottom. Okay, and without even knowing the number you're at, if you're going positives to negatives then to positives, you're never going to have the same number that you're adding. So this is not an arithmetic sequence. Okay, next part. We're going to be writing a formula for AN. So now we're going to start using this equation. Okay, and so we have to know, if you know A1 and you know D, you can write your equation. So if I look at number 5, I have A1 and D already given to me, so I don't even have to find what they are. So my equation says AN equals, okay, I need DN. Well, it says D is 8, so this would be 8N. Okay, I need plus C. Well, how I find C is I'm going to take, says you're going to take A1 minus D. So A1 minus D, 1 minus 8 is negative 7. So that means my equation is 8N minus 7. Okay, number 6. I already have A1 and I have D. So I can go straight to writing the equation. So D is 3x, so this would be 3xn. Okay, then to find C, you're going to take A1, so that's x, minus D, so minus 3x. So that would be negative 2x, so this would be 3xn minus 2x. Okay, 7 and 8. You have A1 and D where it's in there, you just have to find it a little bit. So like if I'm looking at number 7, you're looking at a sequence. Well, first off, you know that A1 is your first term. So if I'm looking at a sequence, I automatically know that A1 is 4. Okay, if you want to know either in your head, if you can figure this out in your head, that's fine, to find D. So if I know what plus 4 give me 3 halves, that's fine. If you want to find it mathematically, okay, if you don't want to like have to think through because you're doing fractions, it's a lot harder, you're going to take the second number minus the first number. So I would take 3 halves minus 4, and that's, okay, so 1.5 minus 4 is negative 2.5. So I'm going to put it as a fraction, so that's negative 5 halves. Okay, now I have everything I need to write my equation. So my equation AN equals DN, so negative 5 halves N. Okay, then I need plus C. So C would be A1, so that would be 4, minus D. So minus negative 5 halves would be plus 5 halves. So that's 2.5 plus 4, so this would be plus 6.5. Or if you want to put it as 13 halves, that's fine. Okay, I left this as an improper fraction because when you have numbers in front of variables, you can't have mixed numbers. So if you just, that's why I left it as improper. Okay, then last one for this part. Okay, so I have, if I'm looking at what I've given, I have the first term, I don't know the second or third term, but I do know the fourth term. Okay, so I have to know A1 and I have to know D. Well, I already know that A1 is 5 because I'm given that. Okay? The easiest way for arithmetic sequences to find D is you would take the last term minus the first term and you would divide by how many spaces it is. So, okay, it's not just 2. You're counting from how many spaces we go. So, 1, 2, 3. So that means this would be 10 thirds. Okay, so it's not by how many things are missing, it's by how many things you traveled to get from the first one to that last one. So then my equation would be AN equals, so I need DN, so 10/3 N, and then plus C. Well, I want to find C, that's A1 minus D, so minus 10/3. Alright, so that would be what? 3 1/3, so that would be 1 2/3. Alright, I'm going to put the next part up there. Okay, I'll have a couple more to add on at the end, but I want to make sure I have plenty of space to do these problems. Okay, so the first part says write the first 5 terms of the arithmetic sequence, find the common difference, and then write the nth term of the sequence as a function of n. Okay, anytime you see ak plus 1, these are the ones that are defined recursively. So the first thing says find the first 5 terms. So I know my first term is 15. Okay, Okay, recursively means that you plug in this number over here, then define your next one. So if I plug in 15, 15 plus 4, my second term is 19. So you're not plugging in 2, you're plugging in the previous term. So if I want to find A3, plug in 19 over here. 19 plus 4 is 23. Want to find A4, plug in 23. 23 plus 4 is 27. And then I plug in 27. 27 plus 4 is 31. Okay, that answered my first part. Okay, then it says find the common difference. So let's see, what am I adding every single time? Well, that means my common difference is 4, because that's what I'm adding every single time. And it says write the nth term of the sequence as a function of n. This is when you're writing equations. So now we're going to take this information and we're going to write an equation like this. So we were given the recursive formula, but now we want to write it as a function of n. So this would be an equals, okay, I need dn, so my d is 4, so 4n. Okay, then I need to find c. Well, c is equal to a1 minus d, so 15 minus 4, which is 11. So my equation would be 4n plus 11. All of that is your answer. So you have first 5 terms, common difference, and then we wrote an equation. Okay, do the same thing on number 10. So first term is 5/8. I plug in 5/8. 5/8 minus 1/8 is 4/8, which is a half. And then if I'm plugging in a half, which was 4/8, minus 1/8 would be 3/8. Then I have 3/8 minus 1/8, and that would be 2/8, which is a fourth. And then a fourth, or 2/8 minus an eighth, would be an eighth. So my D is negative 1/8, because that's what I'm adding every single time. Okay, then if I want to write my equation, AN equals DN, so negative 1/8 N. Okay, then if I want to find my C, I'm going to take A1, so 5/8, minus D, so minus negative 1/8 would be plus 1/8. So this would be 6/8, so if I reduce that, they're both divisible by 2. So that would be 3/4. And this whole thing is my answer. Okay, last part, finding the sum. So this is where we're going to use this formula. Now, I'm going to have to use this first one if we're not given everything that we need. So I need A1, which is my first term, AN, which is my last term, and I need to know how many terms there are. Okay, so if I'm looking at number 11, well, I know my first term is 8, and I know I have 10 terms, but I don't know what AN is because it goes dot, dot, dot. It doesn't tell me what my last term is. Okay, 2 options. You can keep counting until you get to the 10th term. Okay, other option is you can use this equation and plug in what we know to find AN. I would rather do that. So I'm going to use what I know because I already know what the common difference is. I can look up here and see what am I adding every single time. That's 12, so this would be 12. I already know N, I'm trying to find my last term, so I'm trying to find the 10th term. And then I need plus C. Okay, well C is the first term minus the common difference, so that would be plus negative 4. Okay, well 12 times 10 is 120, minus 4, that would be 116. So now I know A1, I know my AN, and I know my N. Now I can just plug them into this equation and solve. So my sum would be N over so 10 over 2 times A1 plus AN. Okay, so I would take 8 plus 116, and then I would multiply by 10 over 2, so 10 over 2 is 5, so times 5. So my sum is 620. Okay, number 12 is the same way. I just want to do another example of the same thing. And actually, I think these are harder than the rest of the problems that you'll have. Okay, I feel like they start with the hardest ones under this section, and then it gets easier. Okay, so I know A1, my first term, so my A1 is 40. It gives me my N, which is 9. Okay, but it doesn't give me my AN because it has the dot, dot, dot. Same thing, I'm going to use this formula. So, common difference, what am I adding every time? Well, I'm adding -3. So I have -3. My last term is my 9th term. Okay, and then plus C. Well, C is A1 minus D, so minus -3. So this would be 43. So if I take -3 times 9 is -27, plus 43, that means my 9th term, or my last term in this sequence, is 16. So if I plug everything into that formula, I have N over 2, so 9 over 2, times A1, which is 40, plus AN, which would be 16. So 40 plus 16 times 9 halves would be 252. Okay, next one. I'm given A1, I'm given A25, and I'm given N. Okay, well, so I need my first term. Okay, done, that's taken care of. Okay, I know N is 25. Okay, now I know this is my last term, because if I'm trying to find 25, this is my 25th term, that means this is my last term. I don't have to find anything like we did on those first two. All I'm doing is taking what I have, and it's ready to plug into this formula. So the sum would be 25 over 2 times 100 plus 220. So I would take 100 plus 220 and then multiply that by 25 over 2. So my sum is 4,000. Okay, we're going to do a couple more sum problems. Okay, so the last ones that we do. Okay, so 14, the sum of the first 100 positive odd integers. Okay, everything that you have is given to you. Okay, you just don't see it because it's not just written out there. Okay, so if I want to find my sum, n is how many terms are. Well, it just says the first 100 positive odd integers, so that means that I know n is 100. Okay, then I need to know, okay, what are those? Well, the very first positive odd integer would be 1. Okay, if 1 between 100, that's 100 numbers. Half of those are odd, half of those are even. So if I want to know the first 100 positive integers, my last term wouldn't be 99, because that just gives me 50 numbers. It would be 199, because I need the first 100. So I would take 1 plus 199, so that's 200, times 100 divided by 2, and that would give me 10,000. Okay, sigmas. If you want to find sigmas, okay, so I need to know A1. Find A1, plug in this number to find A1. So A1, 10 times 6 would be 60. To find AN, you're going to plug in the top number. So 60 times 100, 600. To find n, you take the top number minus the bottom number plus 1. It's always going to be plus 1 because you have to account for that number, because you're not always going to be starting at 1. So 100 minus 10 is 90, plus 1 is 91. Okay, you have everything you need. So my sum would be 91 over 2 times 60 plus 600. So add those together, multiply by 91 over 2. This would be 30,000. Okay, 16, I have two sigmas. I'm going to find my first one, find my second one, and then I do what it says in between. Okay, so if I want to find A1, I plug in my bottom number. So I'm going to plug in 11, so my A1's 11. If I want to find my AN, I plug in my top number, so I plug in, I get 30. To find N, I take my top number minus my bottom number plus 1. Well, 30 minus 11 is 19, plus 1 would be 20. So if I find the sum of this, so I would have 20 divided by 2 times 11 plus 30. So my sum for this part so 11 plus 30 times 10 would be 410. Okay, then I find my sum on the next part. So find A1, plug in the bottom number. To find AN, I plug in the top number. And then to find N, top number minus the bottom number plus 1. So my N is 10. So my sum of this part would be 10 over 2 times 1 plus 10. So it would be 11 times 5. So my sum of this would be 55. Okay, it says we're going to subtract these two sums. So I would take 410